Hello, my name is Tucker. I'm here to tell you about my CS224U project on predicting email response behavior. So email is a big deal. It's been here for a while. It'll be here for a while longer. Billions of people use it. It's worth billions of dollars, but it has some salient problems, one of which is email overload. If you get lots of emails and only some of them are important, it can be overwhelming and difficult to find the important ones. So the idea is that maybe AI can come to the rescue here, which is what my project is about. The long-term goal would be to highlight interesting or anomalous emails for the user so they can act on them. For this project, I decided to limit the scope to building a model specifically for predicting whether or not the recipient of an email will respond to it. That is, reply to it or forward it. There's been considerable work on this over the past 20 years or so. Here's kind of a brief survey of the existing literature. These first two are linear models. The final one is a CNN. The F1 scores indicate that this problem is tractable, though not trivial. So for my project, I ended up using the Enron email dataset, which is a set of 1.5 million emails from senior management at the Enron Corporation. I pre-processed this dataset to extract labels in the vocabulary. Basically, if the email was part of a reply or forward chain, I classified it as action taken. Someone responded to that email. Otherwise, I classified it as no response. I built 3 models, and I'm planning on building a 4th one in this project. I'll tell you about 2 of them. Well, 3 of them, I guess. The first one is just a linear baseline that uses logistic regression on the average glove vector embedding of the words in the email. The second, more sophisticated one is a LSTM, an RNN with it's 2 directions, so it's 2 RNNs, one going forward, one going backwards, with an intention weighting scheme to weight the hidden states. I'm also experimenting or considering experimenting with some sort of collaborative filtering sender-receiver interaction term, which would basically use information about the senders and receivers in addition to the email vector from the RNN to make predictions. So, all right, that's a brief overview. Let's see a little bit about what these models are like. I've got a live IPython notebook here, though I probably will not be running it for the sake of time. This is the bidirectional RNN classifier. I've trained it for about 50,000 data or batch iterations, and you can see it gets a F1 score on around 32,000 examples of about 0.756, which is pretty respectable. You can look at some of the responses it actually makes, since these are actually data points in the development set. So this one it predicted correctly. Let's find one it got wrong. So this one it thought that the email would be replied to, but in actuality there was no response. Does seem to be relatively long. There seem to be for a number of unks, which are these unknown tokens, as well as these num tokens. So there could be definitely some interesting data in here. Oh, this one it said thought no one would respond when it was actually reply, which I don't know. Looking at this, I probably would not think that someone would respond to this email. Another interesting thing you can see is the attention weights. Which are basically, the RNN assigns an importance to each hidden state, and you can kind of visualize these here. So on this example, the model guessed it correctly, and it thought this word leaving was really important. If you look at the loss curves, the training curves, blue is on the development set, orange is on the training set. You do see that there is some signs of overfitting once you get to the later epochs. Anyways, so in conclusion, this is kind of a brief summary of the results I have so far. These are previous models. This is the random classifier. This is the bag of vectors, the linear RNN model, which gets about 0.7. The RNN gets 0.75. And I have not implemented the collaborative filtering model yet. The takeaways are these models can definitely achieve near human level performance, but may sometimes make non-intuitive decisions and mistakes. I'm unsure of how well these models will generalize to other data sets. It seems to be particularly on business emails, so you may need a different model for personal emails. Between now and the paper deadline, I'm going to try to optimize the model hyperparameters, reduce overfitting, implement that collaborative filtering model, and then dig more deeply into the model's qualitative behavior. Thanks.